recording. And we need to make this big. And we need to make this stuff go away. There we go. Let's turn this around so that we get more paper. There we go. Okay, this is a video for my intro calc guys. And on this grade 11 review that we've started the course with now, that we've been playing with for about a week, I've made videos for this section, the factoring section and long division, and that's the entire third page of this booklet is long division. And I've made a video for playing with fractional algebra and fractional algebra that has radicals in it. So there's 3 videos. This will be the 4th video where we talk about some stuff on page 2. So stuff on page 2, for starters, how do these things change that graph? So I'm going to actually go to Desmos. Oops, that's not Desmos. There's Desmos. Okay, so I'm going to start by graphing y equals x squared. Okay, now, actually, instead of y equals x squared, I'm actually going to do f of x equals x squared. I don't know if you knew this or not, but on Desmos you can actually graph things using function notation, which is very handy. Okay, so now, what happens if I take the function f of x is x squared and I add 2 to it? So I go y equals, and this is actually question number 11a, y equals f of x plus 2. Notice that moves it up. This is actually the same graph as if I'd have just went y equals x squared plus 2, right? Right? It's blue, it's green, it's blue, it's green. It's the same graph. So basically it's just saying, what if you take x squared and you shifted it up 2? Well, in this case, I'm saying the function is x squared. I've defined it, and I shift up 2. So now, for the rest of this question, try to predict what the next things are going to do. The B question actually asks you, instead of putting plus 2 out here, it asks you to put, this is always fun, turn off this graph and then see if you can predict what happens when you turn it back on. So I think that this is going to shift this graph, if I remember my grade 11 correctly, 3 units left to the right. Remember the opposite rule works for this one? So yeah, it's going to go to the right. Cool. And again, what's new to you, you did this in grade 11, but what's new to you is you've probably never done this thinking about it in function notation before. The trickiest one on here is what happens, what's the difference between putting a 2 out here, and again, I'll turn it off and we'll guess, putting a 2, oops, that's not what I wanted, putting a 2 out here versus putting a 2 on the inside of the bracket. This is a little counterintuitive. This 2 stretches it up because the y's go up twice as fast. So what would happen if I put a 2 in here? People who've done the grade 12 course have already seen this. We didn't do this kind of thing in grade 11. This is kind of new. Can you predict what it's going to do? It actually stretches the x numbers, which makes the graph look, again, like it's skinnier. So that might be a little counterintuitive. If I wanted it to get wider, I would do that. Okay? So once again, it's kind of that opposite rule that we just had. Why was x minus 3 moving to the right? Because the shift is on the same side of the equal sign as the variable. So you'll play with that, you'll get used to that, and then, let's go back to the actual sheet, then we actually have you do some questions using function notation. For example, let's take one in number 12. I think everybody should be able to do this one. This is my, we'll jump right to D. Looking at 12D, sorry, let me know if I'm off the page. F of x is equal to x squared plus 5x plus 6. Okay? And now I would like to know what f of h plus 2 minus f of 2 all divided by h is. So what is it asking me to do? It's asking me to take this function, the function f, and replace x with h plus 2. Then do the same thing, take the function and replace x with 2, then subtract those things and divide it by h. Okay? Now, people who are watching this video at home, I think you should pause the video and try to do it for yourself. So pause it now. Okay? Did you try it? Here's how it would look. replacing x, oops, I'm off the screen. Replacing x squared with h plus 2 will make h plus 2 squared. Replacing this x with h plus 2 makes plus 5 h plus 2. And then, of course, don't forget the plus 6. So there, that part there is right here. So that's, I've taken care of that so far. Then I have to minus, and I think I might use a big bracket here, minus f of 2. So that's going to be 2 squared plus 5 times 2 plus 6. There. This part is in here. All of this is divided by h. And something really neat's going to happen when you try this. When you expand that, of course, you get h squared plus 4h plus 4. When you expand this, you get 5h plus 10. Don't forget the plus 6. Then, this is all one number, right? This is 4 plus 10 plus 6, which is 20. So I'm minusing 20. And notice what's going to happen here? You're going to get 4 plus 10 plus 6, which is 20, minus 20. The constants go away. It's rather important algebraically that the constants go away because now this denominator, is it 5? Oh, it's 5h. Sorry. Thank you. I made a mistake. I missed the 5h. Thank you. But anyway, the important part that I was trying to get to is that the constants go away, and that allows us to make the denominator go away. So that means I can factor an h out of here and divide by h by itself, and the final answer is h plus 9. That's a very important type of algebra that's going to happen quite a bit when we're doing this course, in that we'll be stuck with an expression with a denominator, and we want that denominator to go away. You'll see why in the next couple of lessons this is really important. But there we go. 12D is kind of a key question on this page. Also key is number 13. So let's just do one from number 13. So for number 13, it says, find the slope of the line that intersects the following graphs at x equals 2 and x equals 4. So the first one it asks you to do is, of course, f of x equals x squared. So let's think about that. Let's go back to Desmos for a sec. So there's f of x equals x squared. When x is 2, you actually know it's 4. Now, I wouldn't let you use Desmos for a question like this, perhaps, on a test or whatever. Let me shrink that down. There we go. And then when x is 4, of course, it's 16. So basically, ooh, come on, 16. Okay, fine, I'll just type the points in. So when I have the points 2, 4, and I have the point, it's 4, right? 4, 16. Sorry, 4, 16. Imagine now a line that goes through those 2 points, a straight line. My job is to find its slope, right? So how do I do that? How do I find the slope? Okay, let's go back to the paper. So the slope is, so if I was doing this without Desmos, of course I plug 2 into here and I get the point that when x is 2, f of x would equal 4, so I have the point 2, 4. When x is 4, plug 4 in and I get f of x is 16, so that's 4, 16. If you've never thought of it before, remember that all coordinate points can be thought of as x, y. Well, when you're in function notation, all points can be thought of as x, f of x. Same thing. And how do you find the slope between 2 points? You just break out your grade 10 slope formula, which is y2 minus y1 over x2 minus x1, which is 16 minus 4 over 4 minus 2, which is 12 over 2, which is a slope of 6, which I hope is the right answer. You can check. Now, it wants you to do the same thing for some different curves. The B curve is a slightly more complicated parabola. The C curve is, remember this guy, it's that funky one where the one arm goes that way and one arm goes that way, but it's still a curve, and if I have 2 points in that curve, I can make a line and say I have a slope between those 2 points. This is setting us up for a very important idea in calculus, and in fact, it's one of the two problems calculus is invented to try to solve. How do you find the slope on a curve? The other problem is, how do you find the area under a curve? In this course, we focus mainly on that first problem. Your next calculus course deals almost entirely with the second problem. So, now that we're kind of getting towards the end of this booklet, we're ready to start calculus.